Hi, my name is Shane Wayne. I'm from Arizona State University, and today I'm going to be presenting my paper, Designing Interactive and Personalized Concept Mapping Learning Environments. So let's start with a brief introduction about what concept maps are. A concept map is a visual representation of knowledge. It has two basic components, concept map nodes, which represent specific concepts, and concept links, which identify interrelationships between concepts. So researchers has been studying concept maps for a long time. So it's been proved that concept maps has a positive effect on students in terms of organizing and summarizing knowledge. However, there are still some problems and limitations in using concept maps. First of all, it has high complexity of the task, and also the task is time consuming and it requires some expertise to create a good map. And also, students who lack expertise often feel demotivated. And what's more, the map itself, it lacks detailed information about the knowledge. So researchers has been designing computer-based tools to help students with concept map construction. One example of these tools would be the CMap tools. The CMap tools allow students to create concept maps in a very easier way compared to using paper and pencils. However, students still need to type in all the words for the concept map, which still requires a certain amount of time. And what's more, the tool itself is independent from the class resource since it's a third-party software. So students might have some trouble to relate the map with the textbook resource. So to solve this problem, researchers designed another tool, CNT, Concept Navigation Tool. So what this tool does is that it automatically links the concept map with some in-class resources like tests and exercises by automatically searching on the keywords appears in the concept map. But the potential problem here is that the students might not be familiar with these content, and it might require additional effort to understand this content and relate the map with these contents. Another way of assisting students with the concept map construction is the use of expert skeleton concept maps. So what this tool does is that it serves, this map is first created by experts like teachers, and it serves as a incomplete template for the students. So what usually appears is that we have a few concept nodes and a very basic structure, and we present this basic structure to the students as a foundation, and then we list other concepts that we encourage students to add to the map on the side. So research has shown that this tool would provide as a scaffolding assistance to the students. However, it's not clear what concept nodes should appear in the expert skeleton map, and what's more, there are some other characteristics like the size of the map. It's still not clear how big the size should be, and also how to design the expert skeleton map to tailor individual students' needs. So to summarize these problems, what I'm trying to answer with my research is first, how do we design expert skeleton maps that tailor individual students' needs? And second, how do we help students to better relate concept maps with the textbook content? So to answer these questions, we develop a concept map based learning environment. It's an iPad based application where we integrate the concept map software with the textbook. So this application has three key features. First is easy concept map construction and personalized expert skeleton maps, and also concept map based navigation. So the first feature, easy concept map construction, allows students to create concept maps from the textbook. So what I mean by that is students can use the words in the textbook and to use these words to create the concept maps. So an example would be, say that we would like to add the word animal into the concept map. So what we do is that we long click on the word animal, then until a menu bar pop up, and then we click on this menu bar, and what would happen is that a concept node with the same word is added to the concept map. So in this way, students are able to create a very complex map without typing in any words by themselves. So we assume that, so we hypothesize that this would preserve the process of searching the words in the textbook, which might help them to learn, but we reduce the time of typing in the words, which might be inefficient. So we hypothesize that this feature would make the map construction much easier while preserving the beneficial process of searching the keywords. The second feature is that it's concept map-based navigation. So since the nodes are all created from the textbook, after the map is created, we allow students to click on the node, and it's going to take the user back to the page where these nodes are created. So what happens here is that we click on the node point source, and it takes the user back to page 1 where the node point source is created. And what's more, all the other nodes that are created in this page are also highlighted. So it provides user with a very straightforward comparison between the nodes in the map, which highlights the knowledge structure and also the where these nodes are created from the textbook, which contains more detailed information about the knowledge. And the third feature, personalized scaffolding. So what we did here is that the design of our expert skeleton map are based on the pretest. So first what we did is that we create a expert map with all the concept nodes in it. So here what we showed here is a portion of the large expert map, and we map the expert map with the pretest. So here this part of the structure is mapped with this question in the pretest, and here our user get this question wrong. The correct answer is flower, but the user incorrectly chose to be root. So what we do in this case is that we delete the node flower and fill in with question marks. So in this way, we are simulating the process of students adding new knowledge into their existing knowledge structure, which might have a positive effect in learning. So we've been running studies to test the personalized scaffolding feature. So our results so far is that we looked at nodes in the map being added by students and not added by students, and our results show that students learn much better from the nodes they added to the map compared to the nodes they do not add. And then we further classify the nodes in the template to be either in template close, which are the nodes that are adjacent to the nodes added by the students, and in template far as the nodes that are more than one link away from the nodes added by the students. So why we do this classification here is that we hypothesize that students might pay more attention to the nodes that are closer to where they added and pay less attention to the nodes that are further away from where they added their new nodes. And our results show that students does learn better from the in-template close nodes than the in-template far nodes. However, the results are not significant yet to show any positive results. That's why we are running another study which is Amazon Mechanical Turk study, to get a more significant results. The participants here in this study is users on Amazon Mechanical Turk, and the period is half an hour. So what we do it in this condition is that students will be presented with randomized incomplete templates. And our goal here is that we are trying to evaluate how different designs of templates could affect student learning. And apart from that, we are also running another study to test the system as a whole. So we are running another study in a high school class, and our participants are high school seniors. And this study lasts 20 minutes per day for 5 days. In this study, we would have two conditions: a hyperlinking condition and a non-hyperlinking condition. And the goal of this study is to examine how hyperlinking would affect students' navigation and the final learning outcomes. So, in conclusion, the research question I'm trying to solve is that to design expert skeleton maps that tailor individual needs and help students to better relate concept maps with the textbook content. To solve this question, we create a concept map-based learning environment which has three key features: easy map construction, hyperlinking navigation, and personalized expert skeleton maps. And we are running two studies to test the system. And this research is funded by NSF, and I'm open to any questions you guys have.